There you go. Okay. So just refer to everyone. Yeah, this session is being recorded. All right. Okay. So yeah, so it's quite interesting to see that like today, as you all can see, like I think we have around 18 peoples, right? So that's a good number for a technology that is so new. And frankly speaking, I've been to so many conferences here in North America, and just FYI, I'm located in Toronto. So there have been so many conferences I've been attended, and no one talks about this part of the world that is like South Asia in India. In this, whenever we talk about blockchain or Ethereum or Bitcoin, if we talk about miners, also, if you see on the graph, there are hardly anyone from our area. So one thing which I always thought, in being from a native Indian, it was always my aim that okay, something if I can get back to India, something we can get started or we can make people learn in India, so that we can also conquer the world the way San Francisco does. In today's world, if you, I think you all will agree that ideas are born in San Francisco and then it reaches back to India. For everything, you talk about payment industry, you talk about internet, or you talk about anything, all the ideas, everything is born, and India is a delivery hub, right? It's the application hub that okay, once the technology gets mature enough, and then only it reaches back there. But this stuff, this distributed ledger technology or the blockchain, this is our one way, or this is one of our opportunity where we can say we can make all those past things go wrong, and we can say that we can also conquer the world, or we can be on top of the world at the same time, at the same time the technology is being released anywhere else in the world. So anyway, that was just a small philosophy on my side, when I started reading about this technology. Also, a quick introduction about myself. So, currently, I'm a founder and I'm a blockchain architect for DLT Labs. In the past, I was head of blockchain technology for R3, and before that, I was a senior program manager at Royal Bank of Canada for the blockchain initiatives. Before that, I have a huge experience, around 15 years experience in the payment industry. So most of the slides you will see, I'll be talking more about payments because that's where I'm coming from. Fair enough. Any question? I know, if you guys have any question, and if that question you think will help benefit everyone, then I'll suggest, then feel free to jump in and start talking. Otherwise, if you think there are certain questions which is just for you, right, like it's for your personal benefit, then definitely I can take those questions later on, or we can set up one-to-one call, or you can write me an email, or there's thousands other ways where you can get connected to me and I can answer those things. But in order to make sure this meeting is benefit for everyone, so let's make sure whatever question we are asking is beneficial for everyone. All right, sounds good.
Neeraj, what we can do, you can go. Yeah, Neeraj.
Yeah.
Yeah, what we can do when you will going through the slides, after few minutes you can ask people to raise questions. So
Sure.
in that case, in that way, it won't be cluttered and we won't be getting questions in a very haphazard way. So if anybody is having question and see if the time permits, we can entertain it on voice. Otherwise, we will ask people to post question on the chat window and we will reply back if
Okay.
possible today. Otherwise, we'll post all the answers on the Meetup group. Fair enough?
Good. Sounds good, Ajay.
Okay,
All right.
then go ahead,
So,
Neeraj.
yeah, thanks. Okay, so if you will see, I have whole lot of things to cover, but I know, like, because of limited time, I'll start with the extreme basic stuff, and then I'll keep on going. Let's see how much of stuff we can cover today, and then if not today, then definitely during the next meetup we can cover it. But before I start, one thing I want to make sure, blockchain, or I should not say blockchain. I'll use the word DLT, and I will say why I want to use the word DLT. This distributed ledger technology is so new that every month a new system is being born. All right. Whatever I'm talking today may not be true tomorrow. Okay. So whatever information I've gathered here is true, at least as of today. But if you think any discrepancy, or if you doubt anything, then definitely we can discuss it out. So as I said, let's start with the very basic thing, right? And why I'm starting here, I know some of you guys already have read a whole lot about blockchain, but there are certain people who have asked us that okay, start with something very basic or fundamental. So that's why I'm starting, exactly what is blockchain, right? So blockchain has a definition, okay, and that's what, I think this is the most generalized description of what a blockchain system is. And it stands, and there are three words here. uh, these three words are trust, accountability, and transparency. These are the three stuff: trust, accountability, which is on the second line of the definition. You will see that blockchain is a technology for a new generation of transactional application that establishes trust, accountability, and transparency. So these three words define what blockchain is. And if you think that in today's world, all the existing system we have, these three words are missing: trust, accountability, and transparency. And going down the line, just keep on these three words, and I will show how this blockchain system is getting this trust, accountability, and transparency, and why in today's world these three stuff are really important. Okay. So just hold on with this definition for now, but we will keep coming up here now and then every time, where I will show that why this definition is the most generalized description of blockchain. So again, to my question, this is how I start, right? That someone asked me what is blockchain. Instead of explaining it by words, I think, I show that person this particular blocks, okay? And basically this is what a blockchain is. So in a very simplistic word, blockchain is nothing, right? As the name suggests, it is chain of blocks. One block, one after the other. Okay. The data is stored in blocks. It is not a new technology, right? Like we keep saying that okay, blockchain is a new technology, but what is, the question is asked that okay, what is new about this about this arranging the stuff in blocks, right? If you are from a computer science field, this is nothing but a linked list, right? A linked list is what? Linked list is nothing. It is a set of blocks, and in each block you store data. So, and frankly speaking, this is what blockchain is. Blockchain is nothing but it is a linked list. That's true, right? And in each block, you are storing data in an organized fashion. And this technology has existed for always. So again, what is so unique about it? Why, entire payment system, entire world is so, they are talking so much about disrupting technology, that this is disrupting the payments, this is disrupting everything, right? And that's what I'll try to answer it. Again, I'll try to answer is why there is you know you see by the in during the end of the block, right? There are two chain of blocks are forming. There's something in middle also, one block, that gray block is coming out. So yeah, we will talk about it, and why that gray block is coming out, why there's two white blocks which is not going in chain, and all those stuff. All right, so yeah, so defining what blockchain, this is what blockchain is. I'll keep going on, and then I'll take some question. Before understanding, or before I can answer that okay, how can I say this is a blockchain, whatever you say in front of you, we need to understand one very important concept, okay? And that concept is about hash. So for a second, I want to spend a couple of minutes on talking about hash. What hash is? Again, if we start talking about technology, if we go to the books, hash has a very complicated definition, that okay, what hash can do and what hash is. There are so many algorithms, thousands of stuffs are available. But here's the most simplistic explanation of a hash. Hash is something, suppose you have a email, or forget about email, suppose you have a document, okay? You There's a document A and there's a document B, all right? Now if you want to verify that content of document A and document B are same or not, then what you will do, right? Again, I'm saying, although this is a very simple thing, but I want to emphasize on this thing, that if you have two document A and document B, then how will you verify that those two documents are same? So I think, very straightforward answer will be that, okay, just take that document, match word by word, space by space, dot by dot, and if it matches, then everything is good. And that's fair enough, right? That's all good, right? But but the question is that the only way to verify, or is that the best possible way available to our humanity to verify two documents? Then the answer will be no. In the past, some of the mathematician has come up with this concept of hash where they say that, okay, if we take any document and put it into certain algorithmic function, which is a hash function, right? You can create a unique set of word which will denote document A itself. So what I'm saying is, suppose my name is Neeraj, okay, and I'm putting it into a hash function, then I'll get a string which will be equivalent to myself, which will be equivalent to name Neeraj. Okay. There are more functionality of this hash function. So how this hash function will work, that okay, whenever there is this hash generator, you put something, you will get a specific length of word. For example, let's take 256. Okay, if I'm putting Neeraj into this hash generator, it will create a 256 length of word which will be unique. So when I'm putting, suppose, everything in small neeraj into this hash function, you will get a certain keyword, certain key, or a certain 256 byte word. But if I make n capital in Neeraj and if I put into it again, then you will get another one. In short, what I'm trying to say is, if there's a document A and I put that document A under this hash generator, you will get a 256 length of keyword, okay, which will be unique to the document A. If you change even a single dot of document A, this 256 word stuff, this 256 bytes keyword will change drastically, not even simply, but drastically. And I can show you all those things. I do not want to go on the practical stuff, but I can tell you how to do it on your laptop. You can go and play with it, and maybe or in next some meetups, I can show you. So coming back to the point, right? So if I put this document A into this hash generator, you will get a unique 256 byte keyword. Okay. Now coming back to my original question, how to compare two documents. So rather than comparing those two documents, what you can do is you can simply compare the hash of the two documents, and if hash matches, then both the documents are same. If it not, then it not. So rather than comparing both the documents together, right? Two documents comparing each other like word by word or byte by byte, which is an inefficient way, you can compare just the hash and you can say a document is good or not. And this hash, if you'll ask me, this is not a new technology, and I'm not talking, something which has been discovered yesterday. This hash has been there, for years and years. All the digital signatures or, certain banking functionalities or cryptography works on this function. So it's nothing new. And if you remember my word, like I asked you that, okay, why we say that blockchain is a new technology? Actually, blockchain is not a new technology. It is just arrangement of some existing technology in a unique way, which somehow no one of us has thought before 2008, right? When this unknown guy, Santoshi Nakamoto, who no one knows who he is, he just said that, okay, let's take this technology, put it together in a certain way, and we can get something, something very interesting. And that interesting thing is blockchain. So one of the things which he used was hash, this hashing function or hashing methodology. The one which is used in Bitcoin, or which is mostly used by most of the blockchain, is SHA-256. I know it's a bit technical word, but we can talk more about what exactly SHA-256 is. But anyway, he used this certain hash functionality. So I think I try my best to explain hash. I want to pause here for a second and see, like, if anyone has any question on this hash, how to generate hash, or any question about what hash is. Because For you, it's very important to understand this hash functionality before I can go to the next slide and explain you what blockchain is. So I'll just pause for 2 seconds and see if anyone has any question.
Neeraj, Ankur here.
Yeah, I'm good.
So I wanted to I'm still not clear on the hash part.
Hmm. So any specific question you have, like which part do you want to, or I can explain everything again if that's the question.
Yeah, because if you're saying hash is pretty much integral to understanding blockchain, then
Hmm.
I would like to understand hash in a better way. You
Okay.
explained about two documents having some characters, putting it in a function, right? So that part I understood, but I don't know how it may be used in a lot of industries since ages, but maybe I'm not that much aware of hash.
Mhm. So see how hash is generated. That's something we cannot talk here because I should not say cannot talk here, but that's a very big topic that how hash is generated. But as long I think whatever I was trying to make you understand that there's suppose just and take it this way. There's a hash generator which is a black box. Okay, you do not know what is happening in that black box. That is a separate topic. We can talk separately that okay, how this hash functionality work. But for now, just take it that okay, hash is a black box, and if you put anything inside this hash, okay, you will get a unique 256 bytes. Okay, and it will always be unique. So as I said that if I'm putting suppose Ankur, if Ankur is in small, then suppose you will get 1 2 3 4 5 for example. Okay, and if you put Ankur with A as in capital, then you will get like 1 5 6 7 9 8. So something drastically will change. Another functionality of hash which you should know is that okay, the output will always be 256 bytes. Again, in our case it will be always because we have designed that black box such a way that always the output should be 256 bytes. That's second functionality. Third, which you should know is that okay, if you get 256 words and you do not know what document A was or what was the input to the black box, there is no way you can figure it out in the back direction. That there is no way that you get that 256 word and you can say that whether in Ankur A was capital or A was small or whether it was Ankur or not. So what I'm saying is like forget about how the hash functionality is generated. Just remember three things that okay, anything you put under in hash black box, you will get something unique. It will always be unique. All right. Second functionality,
Mhm.
if you put anything into the black box, you will get a fixed size of byte. In our case, assume 256 bytes. So anything to the black box, you will get 256 byte. Third, if you have that 256 byte, there is no back way. You cannot generate anchor from that 256 byte. So it's one directional only. All right. So
Okay.
if you want to understand hash, that's a mathematic function. There's a whole lot of cryptography, not cryptography, but there's a whole lot of mathematical algorithms which we have to study. But in order to understand blockchain, just remember three things. Again, I'm repeating: one, uniqueness; two, length; three, one directional. If these three things are clear, then I think we are good to move ahead.
Yeah, this is good.
That
Thanks.
sounds right. Thanks. All right. So assuming things are good, I'll move to the next slide. Okay, where I will show how the things are brought together to form a blockchain. So before I just showed you three like a series of blocks, right? Right, and I said this is blockchain. So let's do a deep dive on this one. So uh, 1 second. Okay, so you see these blocks are connected to each other. That's what these red lines are showing. Okay, if I'm again I'm assuming that people are not from computer background, but if you're from computer background then you will see this is how the linked list is there. But still I'm assuming that people are not from computer science background, so I'll explain in full detail that what it is. So and I'll really go very slow. So you see there are three blocks, right? And each blocks are connected to each other. So let's start from first block, which is the rightmost block. right? Where you see H in the bracket and then there's data in previous header. Uh, Ajay, Umesh, I don't know. Can you see my cursor moving or no? Ajay?
No, Neeraj.
No, Neeraj.
Okay, I think next time I have to, so that I can point it out. Apologies on my behalf, but yeah. So first, like I'm talking about the rightmost block on your screen, where you can see H bracket, and then there's an arrow pointing it to one block. Okay, so this first block is called Genesis block. Now these are the keyword which you guys should note, because you will keep on seeing whenever you will read about blockchain, these terminologies will keep on coming. Okay, so the first block is always called a Genesis block. So the way what is specific about this Genesis block is, when you study more on the basis of this Genesis block, at any point of time you can generate this entire chain, and I'll show you how. So first of all, what you do, this Genesis block on a computer system will have an address, right? Any field on a computer system has an address. That's a given thing, right? That's not nothing unique. But every field or every data on a on a computer system has a address. Okay. In this first block, you see there is some data, right? So you have a space on your hard disk or in your memory somewhere, right? Which has a unique address. Okay, and there is some data. Okay, and in a blockchain system, what you will have to do is you will have to store the address of this block somewhere. If you forget the address of this Genesis block, then you will lose everything, because this is the start of their chain and this is a Genesis block. So this is very important. Okay, so this H bracket, whatever the header address is or whatever is the address of this first block, you will store it securely somewhere. Okay, now when we move now from right to left, I'm moving. When you move from right to left, block 1 to block 2, I'm sorry, from block 1 to block 2, you see we are storing the address of block 2 in block 1, and the same way address of block 3 in block 1, sorry, in block 2, my apologies, I'll repeat. For block 1 on the rightmost side, we are storing the address somewhere secure, so that we do not forget. Okay, then address of block 2 is being stored in block 1 and address of block 3 is stored in block 2, and this way the chain will keep on going and going, and this is what blockchain is. I'm still not done. Like I want to relate why I talked about hash before. I'll come there, but again I'm repeating myself, so I just want everyone to be clear. So again, right from rightmost side, we are storing the address of first block. Then address of block 2 is stored in block 1 and address of block 3 is stored in block 2. Then address of block 4 will be in 3, and so on and so on and so on. Okay. Now, when we say that I'm storing the address, okay, basically it's not the address, but I'm storing the hash of each of the block. Or in other words, I can say that I'm storing the address as well as the hash, whatever way you want to represent it. Okay, and I'll say what do I mean by that. So again, starting from first block, what I'm doing is I'm creating a hash of this first block on the rightmost side and I'm storing it somewhere secure. Okay, that's why it's H for hash. So again, rightmost block is the first block. I'm storing that, I'm creating a hash that is a unique. Now go back to my definition. What is the characteristics of hash is, it should be a unique, so unique value of this data, and I'm storing it somewhere secure. Then what I'm doing, I'm going to block 2, whatever data is there, I'm creating a hash, I'm storing the hash of 2 in 1. Then I'm going to block 3, whatever data is there, I'm creating a hash of block 3 and storing it into 2. Then hash of 4 into 3, and so on and so on and so on. And now now this is the most important thing what I'm going to say. Do you, I think maybe you know, you have already realized when I'm storing a hash of next block in the previous block. Okay, now think about this way. If I'm a hacker, okay, and somehow I got the data of block 3, and if I change it, right, as I said, because of definition of hash, if I change anything in block 3, hash will change right away. That means I will have to change block 2, that means I have to change block 1, and that means I will have to change the genesis block. You see what I'm trying to say? How we have reached, how we have achieved immutability. And this is a very important word now, immutability. Okay, we are saying that if we organize the data in this fashion, we can achieve immutability, which was a topic of research since years and years. There's nothing immutable in this world, especially on internet. But what Santoshi Nakamoto proved that by arranging the data in this particular fashion, we can achieve immutability on internet, or in another word, we can get trust on a trustless internet. So I'll repeat my last sentence. We are achieving a trust on a trustless internet. So I'll take a pause here and see if any question, because if you can understand this part, then you will see, you will see that you have understand the entire blockchain.
Neeraj, this is good.
No, I think this is Pushottam. So I have quick one. So when you talk about linked list, so we say we keep the address of next node, but here you use the word previous. What is the intentional or how? So I just want to relate it with that linked list part because we store the address, uh, next node address, but you have used the previous hash. What that mean?
Yeah. So two things here. When you, like, in this blockchain world, let's not use the word node, because node means a completely different thing. Sorry, not that I'm trying to point it out, but I'm saying, if you will use word node, node means a completely different thing in blockchain. Let's use word block here. So the gray rectangular block you see, let's call it block. I will tell what node means. Node is a completely different thing. Okay. Now when you say here, as I said that, okay, I started that, okay, in a linked list, address is stored in previous, I mean to say, okay, when you traverse through a linked list, every every block, right, stores the address of the next one, right? So here I'm saying, instead of storing the address of the next one, anyway, address of the next one will be stored, that's by given, because it is a linked list. On top of that, I'm storing the hash of the coming or the future block. Sorry if, like, in the past, whenever I said I'm not sure, like, my maybe I was not very clear, so my apologies. But what I'm trying to say, in the diagram, if you'll see, let's study block 1 and block 2. Block 1 is the rightmost block. I'm creating a hash of block 2 and storing in block 1. Purushottam, that does that answers you or no?
Yeah, yeah, I think I can understand the concept. Only that I just my focus is that you have used the word previous, which is nothing. That it is the next block.
When I said previous means always, okay, when I'm talking from the behalf of block 2, then I said that the previous block, that is block 1, should store the hash of block 2.
Okay, okay. So that's why I just want to understand the what the word signifies. So
Sure,
it's you
sure.
are saying that the yeah, that's what. Okay,
Agree,
makes
agree.
sense. Go
Sorry.
ahead.
Yeah,
Thank you. Yeah,
sometimes,
thank.
my apologies, when when you go into the flow, sometimes you miss, we,
Yeah, I think.
I should say, like, miscommunicate the word. So no, thanks for pointing it out. But yeah, basically that's what I'm trying
Yeah,
to say.
yeah. It sounds good. No issues. Thanks. Bye.
Okay, thanks, Parshutta. Okay, so this is a very, again, simplistic diagram that, okay, how a blockchain works. Okay, I will go to the next slide, and again, this is the same thing with a little bit of more detail. And what this more detail is, so the top part, hash chain of blocks, that what we have already talked. So in the previous thing we said that they are data, right? And what these data is, these data are nothing but transactions. Okay, so I'm pretty sure most of you are already know about Bitcoin, right? Bitcoins is nothing but it is a system of payment, right, where you can make payments. And when you talk about payments, everything boils down to transactions. Okay, even in Ethereum, you talk about Ethereum, Coda, or Fabric, or anything you talk about, everything boils down to transactions, how transactions are stored. All right, so I'm not going to spend much time on this slide, okay, because now we are doing a very deep dive at how transactions are stored. But I'll still, on a high level, I'll try to explain how transactions are stored. So transactions are stored in as a Merkle tree. Again, this is an important word. Maybe I'll let you guys search and read what Merkle tree is. But I'll tell you the way Merkle tree behaves is that, again, suppose you have hundreds or 2000 transactions. Okay, on blockchain system you cannot store that 2000 transaction inside the blocks. Otherwise size of the blocks will grow, right? Like, if suppose I'm making a payment, like or someone is like, payments are flowing, they can be thousands and thousands of transactions. If you will combine all those transactions and you try to store in a block inside the blockchain, it will become highly inefficient, right? So you cannot store all the transactions inside the blocks. Okay, and also it's a fact, especially in Bitcoin, the maximum size of the block is 1096 MB. Okay, so in the thing is, right, that okay, you cannot store, maybe I can be wrong with some values, but you cannot store all the transactions inside the blocks, because blocks is something which will travel across the system, or it will travel across the network, right? And you cannot make so much of data travel across. So what you do is you create a Merkle tree. And what Merkle tree is, in so the way it's shown in the example, you have four transactions right at the bottom, which is called the leaf. You see transaction, 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 transaction. So transaction is there at the bottom. Then what you do, you start taking two transactions, like every transaction group of two. You take two transactions, create a hash, and you go up. Again, like rightmost two transaction, you create a hash, you go up, you keep on doing this thing, and you create a master header hash. Okay, so the way I explained the previous thing, think of this way. Now if you store this transaction to now you can store this transaction to anywhere outside the blockchain system, right? As long as you have the header or the hash of all these transactions stored inside the block, no one can go and change this transaction, because if you change even a dot of these transactions, then everything will change. So in the blockchain, be it any blockchain, you don't store the entire transaction in the block, but you just store the hash, or to be very specific, Merkle tree head of those transactions inside the block. I know this gets a bit heavy, but I don't want to go into more details because that will confuse everyone, and there's a whole lot of other stuff we can talk here other than talking about Merkle tree. So I
Yeah,
think,
Neeraj, the trail structure will become very much heavy for the people
right.
from
So
non-computer science background.
I'll
So
just pass on this one, and I'll go on some of the interesting facts, so that you guys don't feel sleepy. So let me pass on a couple of slides. Okay. So I will just name. I do not want to go into very detail. So there's thousands of, not thousands, hundreds of blockchain in this world currently. So there's Ethereum, there's Fabric, there's Enigma, there's Coda, right? But what I would like to talk here is, like, since this is our first meetup, right? Like, let's talk something very general, that okay, blockchain, and why it is disrupting the payment system, and why we really need a blockchain system. So okay, we so far, we talked about what blockchain is, and the power the blockchain has. It is the power the blockchain has is it can create trust between two trustless party. And what I mean is that okay, if there are two people, that is, suppose it's me and Ajay, and I want to do some transaction between me and Ajay, right? And I and Ajay, we do not know each other. How should we create a trust? So in today's world, what we do, we always bring in a third party who will sit between me and Ajay and will say and will be a proof that okay, I'm giving something to Ajay and Ajay is giving something back to me, right? So we always need a third party. And actually, I will speak I think for next 5 minutes, and the end of 5 minutes, I'm trying to show you how blockchain is so helpful for the payment ecosystem. And from there you can see that not only from payment, but you talk about healthcare, lawyers, land registry or stock exchange or anything, why blockchain is so powerful and how it has the potential of disrupting the world. So coming back to my example, if I have to if they has if someone has to do any transaction between two parties, okay, between me, so again I'm taking the example between me and Ajay, I need the third party to be there. Now let's get more specific. If I have to make a payment between me and Ajay, right, how will I do it? Forget, suppose for a second, let's forget that there's no internet banking, there's no credit card, there's no nothing, okay. If I have to pay 10 rupee to Ajay, then there's only one way I can do it. If we are, I think we all are living in this in today's century, not in the barter system. So I have only one way, that I will have a currency note of 10 rupees and I will give it to Ajay. Okay. And how Ajay will prove that he has this money? He will hold at 10 rupees in his hand, saying that he has this money, and no one else can claim it. So that currency, that 10 currency note, it has the unique feature that it is unique. It cannot be reproduced. Well, you can, they are black money and all those things are there, where you make a copy of currency. But I'm talking about idealistic world, where if you hold a 10 rupee currency, 10 rupees currency, then it is unique and the person who hold this currency has that 10 rupees. Okay. This is how the system was working. Now, lots of like in especially the 90s and early late 80s, right, lots of I'll use the word lobbyist, or lots of businessmen came into picture in this payment industry. They said that okay, since number of transactions are growing and they give thousands of reasons that it's that we should move towards online method of payment, right, that we should build a payment, or we should build a system so that we can pay online. Okay, so that's a good idea. That will, because the globalization was happening and lots and lots of things were happening. So yes, we have to move online towards for the payment. So they started in the 90s system. They started building a system. So lots of networks, like Visa, Mastercard here in Canada, Interac in India, we have Rupia and all those things. All those networks start coming in, which started helping banks, and banks started helping consumers. That okay, now you can just go online and you can make a payment. Now we have credit card, debit card, so many ways by which we can make a payment online. So someone is sitting at another corner of the world, you can make the payment. So it's all well and good. But if you start thinking it this way, right, that okay, whenever I'm making a payment, like again, if I'm making a payment from Neeraj to Ajay, so you know if you start thinking about technically, right, that okay, I go to my online banking, I make a payment. So what it happens, right, if you go inside the banking world, there's whole number of systems. There's mainframe, there's middleware, there's security and whole lot of stuff on my bank side. Now my bank takes the money, it give to the network, which can be Visa, Mastercard, or any network, or Discover any network. It gives to the network, then network give it to the third bank, then that middle, the middle bank give it to Ajay's bank. Down Ajay's bank will take that thing and will say that okay, Ajay has received the money. What actually I'm trying to say is this payment ecosystem has become too complicated. And what we are getting at the end of it, the only thing that is happening, that if I'm paying 2 rupees to Ajay and if I have 10 rupees, then in my database there's one subtraction, that is 10 minus 2 equal to 8. And in Ajay's system, if he has 20 rupees, then it has become 20 plus 2 is equal to 22. So basically, there's just two simple calculation involved, that okay, one side debit, one side credit. But in order to achieve it, we have built a monster system in front of us. And we are paying tons and tons of money in order to maintain that monster system. And there are so many companies who are making so much profit just because they are doing transactions, because of the transactions. They are not selling anything, they are not giving you anything. It's just that you do some transaction, then you have to pay. You have to pay the network that is given, right? And that system has become so complicated, and these companies are becoming so huge that yeah, it's you know, you talk to any payment guy, they will say, they are making tons of money. That's not fair. Even banks have started complaining that these networks companies have grown bigger than the banks itself, just by charging for every transaction. Okay, so I showed you in the payment ecosystem, right, that okay, basically what is happening there is just two database of two banks. The problem is they are isolated from each other. In order to connect those two database, and now I'll use a very specific term, ledgers. So both the banks have some ledgers, right? Both the ledgers are isolated from each other. Now in order to make sure that both of these two ledgers talk to each other, we have built a monster system. Now what blockchain is saying, and banks have their own reason, they want privacy, they want AML to be followed, and KYC, and whole lot of different regions are there, that these banks have separate ledgers. Now what blockchain is proposing is that, why do you need this whole big monster system if we can resolve something much more easily? What if we can connect two banking system, or the ledger of two banking system, into one, such a way all those requirements of the bank also get fulfilled? And if I'm paying to Ajay, rather than following all those systems, the two ledgers can talk to each other and just settle out the funds. Because in today's world, so many things are, the settlement is the most problematic thing. All the day during long, you keep doing your transaction using your credit card or debit card, and the end of the day you have to settle with everyone. But what if we can make that settlement real time using some system? And that system is what is blockchain. So what blockchain is proposing it, and what blockchain is promising is that instead of having isolated ledgers, let's have a common ledger where each bank will have their own share, and whatever information each bank want to share with other banks can share over the ledger. So you need not to follow this entire ecosystem. Okay, so again, I will take a pause here to see, I know this is more like theoretical knowledge, but I thought, it's good for everyone to see that, okay, what blockchain is promising and where blockchain can really help. And now those common ledgers can be anything. You talk about healthcare, you talk about land registry. And this is why blockchain is very important for India also, because this is a very promising technology where we can say we can really remove corruption. Because another problem here in India is that we have made system go online, but the problem is the database. Still, people can play with the database, right? Blockchain can be one system where one information, if it is uploaded on blockchain, it cannot be changed ever. The data is totally immutable. So, for example, in case of land registry, if I'm saying a land belongs to person ABC, then no one can go and change. No one can hack the system and say that this land do not belong to ABC, because it once it is on blockchain. So this is what is being promised by blockchain. So again, so yeah, I'll just hold on for a couple of seconds and see if anyone has any question.
Uh, Neeraj, this explanation actually helps. I have just one question. It seems all ideal, because as you said, if there is some mistake that happens and that is being stored in a block, how
Mhm.
to correct that again? So correcting that also is a big challenge here, right?
See, correction. Yeah, if something happens wrong, right, you correct it. That correction will
Yeah.
also get recorded. So as long as that correction is correct, that's fine. For example, suppose I'm saying a land belongs to Neeraj, right? And suppose it was by mistake, it did not belong to me, it belonged to Ajay, but somehow it went there. Then what you will go into the system, you will say, okay, because of this region this was corrected, and there will be a track will be maintained. You see that? What I'm trying to show is that for every stuff there will be a auditability will be maintained. At any point of time you cannot say that, okay, old files were lost, or old files were stolen or whatever. That's the audit.
Neeraj, let me put into
Sure.
to just explain it in a more layman thing. Ankur, it's just like an accounting book where you keep accounting records. So you say somebody has paid you 100 rupees. So in this world, what will happen is if you make a wrong entry, you will make one more entry to make it correct and record that entry as a correction entry instead of going and deleting that old entry.
Got it.
Did you get what I tried to say?
Yeah.
So
Yeah,
yeah,
like see, it's basically yeah. Then so okay, then we are fine. Let's go ahead.
yeah. So the thing is, right, the concept of blockchain is that there should be an auditability of each and everything. If you have made a mistake, that should be auditable. If as long as it is an honest mistake, that's fine. But take it this way: if someone wants to, break the system, this is the only way. You can say that, okay, this system is totally immutable, and no one can just come in and break the system and do something wrong. And that's why this, and also you use the word idealistic. Basically this is not an idealistic, this is a real world scenario. I've been working, which I cannot talk about my all my project because of the NDA. Sorry about that. But I can say, here in North America, there we are building so many systems already, which some of them are already out. And if you will search, blockchain system in North America, you will get whole lot of paper. Even I will say, last month, not even last, yeah, last month is February, right? RBI has written of their first paper on blockchain. Again, don't confuse cryptocurrency and blockchain. Like so far, whatever I've talked about, don't confuse what Bitcoin is. Whenever RBI is writing a paper, or Bank of Canada is writing a paper, or Singapore government is writing a paper, they are not talking about cryptocurrency, that is Bitcoin or Ether or all those things. They are they are using this blockchain functionality in order to build a application which is immutable, right? Because this is the only system currently in the world, or this is the most promising system which really challenges this, this, that how this corruption can be eroded from this, I'll say, this humanity, right? Because it's so deep rooted that a normal system cannot just, you cannot just ask someone to stop doing the corruption. You have to stop everyone. You have to make a system which is so strong that no one can just go and hack, or no one can just go and play with it. And that's what blockchain is trying to bring into this world, and that's why people are so excited about it. Well, if anyone has any more question or any other thoughts, if you guys have, feel free, to jump in, and let's talk more.
Hi Neeraj, I have one question.
Sure.
So basically, when you say that systems across the world,
Mhm.
going from banking to hospitals or any other systems, right? So there'll be a different set of standards for each of them. So
Right.
how manageable will that be?
Yeah. So that's a really very good question. And so yeah, the so here I will reinstate the problem, in a more specific way. So basically, what you are saying that, okay, there are healthcare, so there are so many banks, and there are so many organizations. If they all start adopting their own blockchain, then how will you connect all those blockchain, or should I say that how will they connect all the ledgers? Am I framing your question right?
Yeah, yeah, right.
Right. So already the answer is already whole lot of research is going on that, okay, how can you connect different blockchain? And one of the best answer today is, if you know this company Ripple. Ripple is another company who are in this blockchain field, and they have done whole lot of proof of concepts on international money transfer. Okay, so they have come up with this concept called ILP, Interledger Protocol. And what ILP shows us, again, I cannot talk everything about ILP because it's huge, But this ILP is trying to resolve the question which just now you asked. ILP is trying to set up a protocol where using which, if suppose they are if this, suppose there's RBI in India and Bank of Canada in here, right? And they both are using different blockchain. Using inter-ledger protocol, both the ledgers can talk to each other on a ledger level. So still you do not have to build a monster system in order to talk to each other, but two ledger or two blockchain can start talking to each other using this ILP. Also, there's this firm called or a project going on, Hyperledger. Under Hyperledger, there are number of blockchain, and still they are trying to answer the same question that okay, suppose there are like tens or twenties or hundreds of different blockchain, how these blockchain will start talking to each other. So one thing, yeah, today the only answer is ILP, Interledger Protocol from Ripple. But apart from that, there are so many research already going on to resolve this problem that okay, if different government bodies or different bank adopt different blockchain, then how these blockchain will talk to each other. And all these big blockchain system like Ethereum, Fabric, they are already talking to each other to make it interoperable. Sorry for that tongue twister. So that these systems are interoperable. So if you will search, you will find so many white paper written to make sure that how a system can be interoperable. So today we do not have any practical answer, but in coming days, yes, we will have a practical answer to this interoperability. Does that answer your question?
Yeah, yeah, thanks.
Okay, but yeah, definitely take a look to that ILP. Search about ILP Ripple. Sorry, ILP Ripple, and you will see what I'm trying to say.
Yeah, sure.
Neeraj, sorry to bring up a question that might not related to this.
No,
You
no
just
problem.
talked about Ethereum and Fabric are interoperable, right? Or you say so
No,
so
no.
so Ethereum per se they have got their own currency, right? Whereas Fabric does not have anything
Mhm,
similar,
mhm.
right?
Right.
So I'm just wondering how both of these are able to communicate or how they can talk, how your this interoperable thing will apply over here.
Okay, sure. So one thing, as I said, I did not say that Ethereum and Fabric can talk or are interoperable. What I said that the talk is on to make them interoperable. So today, neither we have any theoretical or practical answer to make both these system talk, but in coming days we will have. I just want to make clear. Okay, that's one thing.
Okay. Okay.
Second thing, you talked about currencies. Okay, that Ethereum has a currency, Fabric do not. Right. First of all, the reason why Fabric do not have a currency and Ethereum has a currency. Again, for that we have to do some deep dive, but I will try to explain on a high level. Ethereum, you can run on a public network, as well as Ethereum you can run on a private network. What I mean is, for Ethereum there is a main network running, okay, where all those miners and currencies is floating and everything is happening. But at the same time, I can take the software of Ethereum, which is Geth or ETH or whatever version, and I can start running on my own. So I can create my own blockchain. Okay. Whereas in Fabric, it is not run on a public network. Neither it is designed to run on a public network where anyone can come and join the system. Again, in Ethereum, it is running on a public network that okay, anyone can come and join it. Also, I can run my private network. So there's two flavors of Ethereum, public and private. Whereas Fabric, there's just one flavor that is private, and that is also it's a membership system. So not that anyone can come and join. In Fabric, they have the identity system where only certain nodes or certain people or certain organization who I want to can come and join. Okay.
Yeah.
Since in Fabric there is the identity system. Okay. I know when suppose if whenever I'm running a Fabric private system, I know that okay, these five people are running. So I already know those people that these people are running the system. So you do not need how should I say? So you do not need a way to prove that okay, each node need not to prove to the system that I am dedicated to the system. Okay, I'll try to explain this way. Suppose there are four banks, A, B, C, D, right? Four banks came together. They made a decision that okay, we want to run a blockchain. They took a fabric and they are running. Okay. Now all the four banks trust each other because they know each other. So with the help of identity system, which exists in the fabric, they will know each other. So you do not need any currency there. Okay. Or I should say, you do not need any assets there in order to prove yourself that okay, you are dedicated to the system. Whereas since Ethereum was mainly built for the main network, and we needed miners because we need miners someone to run the system. So that's why the concept of currency is already there. So whenever I run in a private network, that concept is still there. It's just that I can say that everyone will have millions of ether, and but it is private. Those the value of those ethers are nothing. It's just that it is you can say it is a known stuff. It will be there for always. It's just that you will not use that feature in the private network. But when you're talking about interoperability, this currency has nothing to do. If you want to downgrade or downplay the currency feature of Ethereum, you can downplay it. Don't use that feature. It is just there so that you can run it on the main network.
Mhm.
I know it got a bit complicated, I'm not
No,
sure, like,
no, no, Neeraj, I think that helped. That helped.
okay,
I could make
fair enough,
understand that.
right? Yeah, because yeah, take it this way always. If a system has currency feature, that means they want to run it on the main network, like they want miners and everyone. Whereas Fabric is not designed to run on the main network. It is designed to run in a closed network. You cannot take Fabric and make it run the way Ethereum or Bitcoin works. It's not designed that way. Okay.
Yeah.
Anyone else?
Uh,
Any question or any point which we can discuss
oh
now?
yeah, Neeraj, Purushottam here. So one quick one.
Mhm.
So does that mean that it's the blockchain throughout all the intermediaries from the maybe any payment system or whatever the transaction system or any other system? Does that mean?
Yeah, well, straightforward. Although I should not say, but yeah, don't ever quote me. But yeah, that's the plan of blockchain system, right? But
Okay.
but the thing is, no one will go out, but the role of the players will change. Take it this way.
Mhm.
Till now, all the payments related project were done by banks, right? Like credit card or anything to do with payment was done by bank. Now is the first time in the history you will see telecom companies are coming into this payment system. For example, Apple Pay. You all know Apple is one of the biggest player, and I've worked on Apple Pay. I know how big Apple Pay is and how much banks wants to implement Apple Pay. And Apple is not a payment company. They are not a bank, but they are ruling this world, right? Same way in India, Airtel payment is coming. Paytm, we all are seeing it right away. So you are seeing there's a shift in role, that who is doing what. So in coming days, again, it's my personal view. The way I see, once this blockchain goes to production, there will be a change of role, that who is doing what, because still you will need some people or a company to run the system or to support the system. I will not say run the system, but to support the system. And that's where the role will start changing. I think the most important, the best practical example is study Ripple, how they are challenging Swift. But at the same time, Swift are also coming. Excuse me. But at the same time, Swift is also coming with their own blockchain system. Not their own. I think they have partnered with Fabric, if I'm not wrong. Right. So you will see a change in role, rather than those roles will totally go away. But what you will definitely see is a much simplistic system than what exists today. Does that answer,
Okay.
Purushottam?
Yeah. 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 That makes sense. Okay. Thank you.
Okay. Anyone else? Ajay, how are we doing with time? I don't know how much time we have.
We are left with some 20 minutes. Neeraj, can you also introduce permission ledger? It was asked by one of the
Oh, sure.
member here.
Okay, yeah, sure.
I
Uh,
think we did cover private blockchain a little bit while earlier, so if we can do that also.
yeah, so I think we can cover what we can do is uh, 1 second, give me 1 second. Yeah, I thought I will cover this, but mining, like, you all know, right, that there's a difference in mining time between Bitcoin and Ethereum. I could have explained why there's a difference, but since permission level, let's
Yeah, that is an interesting topic.
yeah, but I think
Yeah, actually,
sorry.
Yeah, but I think that will be more better if we cover
Per-
this permission ledger thing, because that will cover the basics.
Sure, sure. So let's talk about permission ledger, and also let's talk a little bit about Coda. I don't know you guys have heard about Coda or not. This is the brand new blockchain in the market from R3, and it became open source, I think, end of October sometime. Okay. So when we talk about, and there's Enigma from MIT that is still not out. Okay. So let's talk it this way. Fabric, right? From IBM, that is one permission ledger. Coda is a semi-permission ledger. Ethereum is a is again, Ethereum is always very difficult to describe because it's so generic that it's not a permission ledger, but you can make it work like a permission ledger. And I keep hearing that, okay, enterprise Ethereum is going to come in coming days. That's a different thing. I do not know how this enterprise Ethereum will work. It is a permission or a open. But let me describe from definition wise what's the difference between a permission and an open. So as I was trying to explain, again it goes to the same talk. If you talk about Fabric or if you talk about Coda, these blockchain systems are defined for certain use case. They are not at all designed for a cryptocurrency. Although, yeah, you can run a cryptocurrency, you can do anything, but basically they are not designed for a cryptocurrency. They are basically designed for a certain use case. They are designed for so that big organization, banks or healthcare or governments can use it. Okay. And again, when what exactly by we mean by permission is, okay, before I go this way, like, let's talk about Ethereum. I said, right, Ethereum can be run in two ways. One is the main network, that is network ID 1, which is already running. Also, you can run privately, that, okay, four banks can come together, they all can run one node of Ethereum, and they can start exchanging transactions among themselves. Suppose now these systems are running, okay. Whenever you do a transaction on node A, it will go to all the four node, regardless whether you want or whether you do not want. That's point one. Again, I'm repeating. On Ethereum, as of today, if there are four banks A, B, C, D, if bank A does a transaction with bank B, whether bank A wants or do not want, the transaction will be replicated on all the four nodes. That is, there a transaction between A and B will be known by A, B, C, and D. Okay, whether you want, whether you don't want one, there's no way to stop it. That's how Ethereum is designed. That's one. Second, if you want to add a new bank, that is bank D, it's very easy. Again, it depends on use case that it's good or not good. But in Ethereum, you have to spin up a new server, load Ethereum, and connect it any one of the existing node, and it will get all the data. So you see, it's not permissioned. You cannot make a permission that what all information a node see, or you cannot make a permission based system that, okay, if that whether a fifth bank can be added or not. So technically you cannot make it on Ethereum as of today. Maybe in enterprise Ethereum you can do, I do not know, but today you cannot do. So that's why we say that Ethereum is an open system or an open blockchain chain where any of the node can come in and get connected very easily, and this is good also in a way, right? Again, whatever I'm explaining, don't I'm not saying that, okay, one is good or one is bad. I'm just saying that, okay, this is how it works. So that's how Ethereum works. But when we talk about Fabric, they have this membership system. So now if four banks are running, okay, those four banks will run Fabric node, but they also have a membership system where if any bank has to join, it's not that easy that, okay, run a node and just connect it with any node and you will get everything. No, you have to get specific certificates from a membership system which is run by all the four existing nodes, and then only you can join it. So you will have to have specific certificates. You need to have several separate keys, private and public key pair, and whole lot of stuff you have to need to do in order to join the system. Again, this is by design. It's not made to make the system complicated, but it is by design from Fabric. Okay, now we go to the next level, Coda. Again, they have this private system where this membership identity works, right? And on top of that, what they have done is, as I said, right, in Ethereum case, if I'm doing a transaction between A and B, then regardless, bank C and D will also know about it. But whereas in Coda, the way they have designed is that if I'm doing a transaction between A and B, C and D, although they are part of the network, but they will never see that transaction until and unless I don't want to show them that transaction. So again, in Coda, the way it works is that if I'm doing a transaction between A and B, then only A and B will see the transaction. C and D will not even know about the transaction, although they are part of the network. So this is the way how they are controlling the permission. It has several negatives also. It has several positive things also. Okay, but what I was trying to explain here is what is the difference between permission and non-permission ledger. In non-permission ledger, regardless of anything, the transaction will be open. Can be seen by everyone. Okay, and anyone at any point of time can come and join it. That is Ethereum. Whereas in Coda and Fabric, it works bit different, right? And Coda and Fabric also work differently, where you just cannot come and join the system, or you cannot just join the network, but you have to come, ask the or ask the administrator of the system that can I join. That administrator will grant you access, and then only you can join the system. So it is a permission system, right? And Coda is one step ahead, that even the transaction you can make a permission, that who sees the transaction, that you can decide. If you want that everyone has to see the transaction, yes, everyone will see it. But if you want only two people to see the transaction, only two people will see it. But this feature of Coda comes at a cost. In specific terms, and also it's written in their white paper, Coda is not a blockchain. That is a DLT, distributed ledger technology. And now I'm jumping from one topic to another topic. So DLT is a superset. DLT is distributed ledger technology, and blockchain is a subset of DLT. Okay. So talking about Coda is not a blockchain. It does not stores information the way we just talked about. It has a whole different concept again, and we can talk about how Coda works, but that will be a completely different topic. But yeah, coming to our original question, permission ledger, yes, that no one can join the system. There is a control how the system will work, and that's what bank want. Bank do not want a complete open system, but there are thousands of other use cases where you need an open system, and which Ethereum support. And again, on Ethereum, you can build a permission ledger, but that's something you have to build on your own. The system do not provide that permission, but in Fabric and Coda, the system provide that permission. So does that answers the question, that difference between permission
Uh,
and a non-permission ledger?
yes, Neeraj, that helps. Neeraj, just one quick question here. I saw two conflicting lines. I don't know if I noted it incorrectly something. You said in the beginning, Corda is from R3. It's a brand new blockchain, right? And now when you concluded, you said Corda is not a blockchain.
I agree.
So
I agree. Okay. Yeah, because why I said that, if I would have said, like, I wanted to explain basically, okay, take it this way. Everyone knows blockchain. Very few people know that, okay, what is DLT, right? But this is how the story goes. There's DLT is superset, distributed ledger technology, and then under that, blockchain comes in. So yeah, if I would have said that, you know, just for ease, I said that, okay, Coda is a blockchain, and that's how most of the people take it. But no, Coda is not a blockchain. Coda is a DLT, but it's not a blockchain. And why I said that, that's the only reason was, if I would have said at that time, it would have made people confused. That's the only reason.
okay,
But thanks for pointing it out for everyone's clarity.
fine. So you said CODA, the additional membership identity. So there is a transaction level permission is there, which actually comes with a cost, right?
That's true.
So maybe we can say, though we say CODA is not a blockchain, it's a DIT,
Mhm.
but we can still say it's something similar with maybe more security feature, right?
They say it is a blockchain inspired system. So, okay, Coda has its own history. What
Okay.
I will tell you, and that will answer your question indirectly. What happened is, okay, Ethereum was there, then Fabric came in. So, what these people said that, okay, Ethereum was a generalized, okay, it's a generalized blockchain. Same Fabric was also generalized, more or less a generalized blockchain from IBM. So these R3 people, what they did a year ago, they started going to the banks and they form a consortium of banks, right?
Mm-hmm.
They said that, okay, all the banks come together and you tell us that what's your requirement for a blockchain system. That if you want to implement blockchain, what all things you want. Okay. All the banks, they
Mm-hmm.
started giving certain requirements to these people. And based on those requirements, they came out with this system. Okay.
Mm-hmm.
So this is a blockchain. Say again, the Coda, they say they are Coda is not a generic blockchain system. They are mainly for the financial stuff. Maybe you cannot use for you can, and you cannot use for sure, not maybe, but you cannot use for all the use cases. It's specifically designed for financial transactions.
Mm-hmm.
So it's very specific. It's for a specific need of the banks or the financial institution, and that's why it is designed that way. Now it is good or bad or what? There's a whole lot of discussions going on. Means I'm no one to say that thing, but yeah, that's how it works. And yeah, that permission at transaction level, it comes at a cost that now I think that question, so I'm very sure someone will ask me in coming days, or it might be in your mind, that if transaction is being shared between two of the system, if one system goes down, then what? How are we making data available? Because data will be lost if one system goes down. So yeah, we do not have answer right away, or I'll say, I don't see any answer right away, but I'm pretty sure they will come up with some solution in coming days.
Okay.
I know I did not answer it directly, but you see, like Coda is first specific product for a financial institution.
Mm-hmm.
Just to add more into it, for from a purist point of view, working on a blockchain technology, that person will not consider Coda as a blockchain.
That's true.
Correct me if I'm wrong,
Yeah,
Neeraj.
it's in their white paper, so there's nothing. They themselves,
Right,
they are not a blockchain system, but they are a blockchain inspired system.
right.
Any other question or any topic which we want to talk?
No, no, this is good. I just had like I was you showed a slide that talks about mining and you wanted to cover that, but somehow you got pulled
Okay.
towards talking about the permission.
Yeah,
Please, yeah.
sure. Okay, so yeah, okay. So actually, my plan was that I should have talked about mining first, and then I should have told a difference between Bitcoin and Ethereum. Why there's a difference in timing, right? So are we all like, do we all know mining? And then only I can talk about difference in time. Why Bitcoin takes 10 minutes and Ethereum just take 14 seconds, or if because it will take some
Mhm.
time, and I think we just have 6 minutes left.
If you can just cover mining briefly, I think that will help
Sure.
because few
Okay.
things are
Yeah.
getting
Sure.
mixed up.
Yeah. Sure. So see, mining goes back. Again, it's if why the term mining, because Bitcoin is considered today's gold, and there are certain reasons why Bitcoin is set today's gold. Okay, like because it's limited, it's costly, it's driving entire cryptocurrency universe. That Bitcoin is the base currency, the way gold is today. It's a standard. Okay, that's why everything is compared between gold and Bitcoin. And gold, you do not manufacture gold, or it cannot be created. Gold is mined, right? It's mined from somewhere, and that's why mining, from there the terms comes in, because you cannot create Bitcoin. You do create Bitcoin, yeah, means it gets created automatically. You do something else and it automatically gets created. Okay, and now I'll explain that how it works. So now whatever I'm talking about, public network, nothing to do with permission. All right. So how this Bitcoin works is that, okay, you have nodes. And remember I said that, look, let's be very specific with the terminology. Nodes are, what are nodes? Nodes are a single server in the blockchain system which are capable of doing anything on its own. So suppose there are 50 servers, okay, or there are 50 servers, right, who are connected with each other using this Bitcoin protocol. This Bitcoin system will be up and running as long as even one node is up and running. Now, I'm pretty sure someone will try to ask me that what about it, 51% attack and all those things. I can answer all those things and I can prove what I'm saying, how it is correct. But this is true that in a Bitcoin system, as long as even one node is up and running, the entire Bitcoin will be there. Okay. Now, what is mining? Now, remember I was talking about hash and all those things. So again, I'll not go into the technology and all those things that I can cover later on, but here's how it works. In Bitcoin, the Bitcoin protocol, okay, or take it this way, I'll go one step back. The aim of Bitcoin network is to distribute the data to everyone and anyone can put in the transaction. That's what Bitcoin wants. That, okay, whatever data is there is used by that data, the replica of that database is with everyone. That's point one. Replica is with everyone. Second point is that anyone in the Bitcoin network can insert the transaction into the Bitcoin network. Now, if when we are saying that anyone can insert the transaction, means so someone has to control it, right? That, we cannot say that everyone insert the transaction. Then how we will do it? The biggest problem is how we will avoid double spend problem. For example, suppose there is a node in Russia and there's the node in Canada. There is a time lag, right? Over the internet, there is a time lag. If I go and spend 2 Bitcoin in Russia and quickly come in North America and I spend the same 2 Bitcoin here, how we will control it? So all these transactions has to be timed and organized in a linear fashion, right? Now, how to do is we have this concept of proof of work, okay? And now what proof of work is that what happens is at the start of every 10 minutes, there is a puzzle given by the Bitcoin protocol to each of the nodes in the system. Okay, so there is a puzzle given to each of the node in the network, and it is said that whoever will solve that puzzle first will win, and he will get an opportunity to write the system into the Bitcoin blockchain. Okay, again I'm repeating, there is a puzzle given to each of the node. Whoever will solve that puzzle first will get the right to write the transaction into the Bitcoin blockchain. And since this person has won the system, has won the puzzle, he will get in today's world 12.5 Bitcoin. So what will happen is once the puzzle is solved by some node, in order to reward that node, Bitcoin protocol will generate 12.5 Bitcoin on its own from nowhere. It will just generate 12.5 Bitcoin and it will give to that particular node that, hey, you won, congratulations, take it. So this generation of Bitcoin, because this is where the Bitcoin is getting generated, this is called mining. And that's what there are so many miners over the world who at every second, they are trying to resolve this puzzle so that they can get this 12.5 Bitcoin. And again, sorry, like I will stop here. This was in a most layman term that, okay, what mining is, but there's a whole lot of algorithms and protocols there, which, definitely I can cover up in our next meetups. If I think, we can see like what everyone is interested in, that's why, we can start talking about that. But for now, does that help or no? Sorry, I didn't know who asked that question. Was it Chaitanya or someone else?
I also do not remember. I think it was Ankur, maybe,
Okay. Anyway,
because Rahul wanted it to postpone this thing to the next session. Anyways, I think Neeraj, we should end this session now. It is already, we have passed the time.
right. So anyway, yeah, then I can say, thank you so much for everyone for joining the session. And plus, for any specific questions, feel free. So here's my email on the screen. Feel free to email me or be in touch with Ajay or Umesh because I work very closely with them. If you have any specific question or any specific requirement or anything we would like to talk about on education purposes or anything, then definitely, we can get connected one to one. I can find out some time, we can set up some call, and definitely we can work out together. And definitely in coming days,
And in case of,
more sessions
Yeah,
like this.
yeah, can you share the recording? Is it
Yeah,
possible?
yeah, definitely. I will
yeah,
give me a day or so. It's just that I have to run for some other stuff. But definitely in coming days,
Sure, sure.
I'll share. Like in couple of days,
we will share the recording link in the Meetup group, in the discussion
Sure, sure.
forum. And guys, if you have
Definitely,
any
yes.
question, sure, just put it down in the Meetup group, and whenever any one of us get the time, we'll reply it for sure. And try to be in touch there with us, and we will let you know when the next meetup is going to happen.
And the only request is,
Sure.
next time we can do some survey. So, guys, if you can ping us, tell us that what topic, especially you are interested, like for example, mining or Ethereum coding or Solidity or anything, that will help us, that will help me actually, to be well prepared in order to present it. Okay, and that
Yeah,
will
actually,
help us.
Neeraj, we did one survey, but yeah, I had started one survey, but the response was not very much, so we
Yeah,
couldn't
so that
collect
will.
any
Mhm.
lot of stats from it. And presently, also the number of people who had RSVP'd as yes was a huge number, and I do not see that many people turned in here.
Yeah.
So, but
But no, yeah, that's fine. But yeah,
thing
thing is,
like this happens.
see, my aim is, to spread this
Yes,
knowledge to as many people as I can. So I will be very happy when I can educate one people on this technology. So that's my aim. But yeah, we will keep doing our work. And whoever joins, I'll be more than happy to explain or
Sure,
impart
sure,
whatever I have on my side. All right.
sure, sure.
So guys,
Thanks a
I have
lot.
to. Yeah, sorry, someone is saying something.
Yeah, thanks a lot, I said.
No problem. Thank you so much, guys. I have
Yeah,
to run. So, but definitely we'll be in touch. All right.
sure,
Thanks,
sure, sure.
everyone. Have a good night.
okay, bye
Yeah.
everyone.
Bye.
You too. Bye.
Bye.
Thanks everyone. Bye bye.